to all of you. I know early morning, third day, already you have had cognitive overload of all things AI happening in India. So let me increase a bit of that overload in the next 30 minutes or so. I'll be speaking about a couple of just business-driven use cases and how we are using satellite images, a very alternate form of data, to create value for enterprises using AI. I'm Prateep, the founder of SatSure, and just a bit about the company. We are a startup. It's been 6 years, and we started actually by initially building the solutions. There have been commercial companies in the US, a couple of them in Europe, who have been operating the satellites, but application building on satellite imagery was not very common until, let's say, the AI wave, the big data, and the cloud wave in the mid 2010s hit. Now, SatSure started at a downstream, data solutions. And as we started scaling the company, the solutions, we understood that from a platform side of things, how do you ingest the data, transport the data, models, etc. They are quite different and unique to the kind of data we are handling, which is not flat file data. These are satellite images which are taking observations in different bands of the electromagnetic spectrum. Today, as we cross our 7th year of SatSure, we are structured as a full-stack Earth intelligence company. That's the term, Earth intelligence, where the solutions that we are building are almost like a SaaS solutions. The platform is something that's cloud-hosted, and it's very custom to orchestrate geospatial data flows. And next year onwards, we are having our own satellites going to be up in orbit for the data collection activities as well. We are a post-Series A company, to be honest, and this is a bit of who are the people who back us. And I'll now, without wasting any time, get into this couple of solutions and how AI is being used on top of satellite images to create value. First, let me just give a basic understanding of the sectors we work in, because I can't cover all of them in the 30 minutes. So we started our solutions for agri-lending specifically, and that's why the BFSI space is there. But we expanded that into utilities and aviation while we built out a platform which today catalogs the petabyte, about 3.5 petabyte of data, and is capable of generating the insights on its own, has visualization layers. And as I said, this is a continuous process for us. On a weekly basis, we are monitoring like 1.5 million square kilometers of area and collecting 72 different parameters on at that kind of scale. A few applications, and this is again a summary that we enable, are across different business verticals. So for example, in utilities, we are helping companies transition from physical surveys to digital surveys. In insurance, we are enabling automated claim settlement, especially when the area of damage is extremely large and you need the loss adjustments to be done within a certain number of days. That is a customer experience requirement for the premium holders. And as I said, in banking, we have, and you would have seen a few logos of banks also on as our investors. We moved the needle from a 30-day journey of lending to farmers to now a 30-minute journey, which RBI recently packaged properly into a much larger unified lending interface, the next UPI digital public infrastructure. So I'll directly dive into one case study to make it very, very easy to understand. And this is where the fun begins. See, in the context of power lines and railways, we have something called as right-of-way. Have you heard of right-of-way, anyone? No? There's some, okay. So right-of-way monitoring is a very important part because it comes as a part of a compliance, it comes as a part of a risk. You can have people in India building huts and farming in the right-of-way, but more often than not, it is the vegetation around the right-of-way which can be a very risky proposition. Recently, I think early last year, there was this massive wildfire in California. While we all saw the news of that wildfire, I think many of us missed that there was a $7 billion fine on one company, a utility company. And that was because they had not done their vegetation cutting properly. And that was the reason. High voltage lines, dried leaves because of high temperature, and it ignited. So if you look at it, the opportunity size, because we are looking at technology-enabled climate adaptation. So about $100 billion of losses happens just because of this problem. Wildfires, flash floods, which causes trees that are taller than the power lines and within that right of way fall on the power lines and cause outages, cause potential damage in and around the biodiversity. Now, how do people tackle that? Obviously, they have their own means. The first and foremost thing is people. Send people, keep monitoring, collect data, and understand where to prune, how much to prune, whether to chemically treat those places. Can you guess, on an average, how much a company in the utility spends just for vegetation management? It's a small component of the operations and maintenance. Any guesses in millions of dollars? $30 million. $100 million. That's more like it. $100 million per company is the average spend just on vegetation management. So, and yet, despite that, it's not always the most efficient thing. Indeed, this is one problem we saw is solvable by satellites much more easily. Why? Because you can scan wide areas. You could potentially do this much faster than humans. You could potentially collect the data at least in a more transparent and trustworthy way. The only problem was the precision at which you collect that insight. That insight being, are the height of the trees going to be more, or the span of the tree going to be within the ROW here. So that is where AI comes. Now, how do we model the height of trees, especially in forests, etc.? I'll come to that, but let's look at how are we enabling a value proposition for utilities. You take the satellite images, you identify the risky areas based on the proximity, what we call as to the towers within the right of way, and that helps them to prioritize the resources. That let me send my resources to the highest risk areas, let's say the ones which are in reds there. So they can create their plan of pruning or chemical treatment and schedule it well, and not just schedule it well, they can use, again, certain clustering, etc. methods, looking at accessibility, road network, density of the canopy, elevation slope, to define what kind of machinery to take to the places, which places to prioritize on a day-to-day basis, how do you navigate, how much cost will come, automate the work contracts, which is where the user operations team says, and then be able to audit also that whether the amount you're paying for is actually the work done. For example, a lot of cutting used to happen for, let's say, 5 meters of the tree, but it was contracted for 5 meters of certain patches, but they will do only for 3 meters. The way people verified was mobile pictures. You can't do much even with AI on that. So, how we tackled that was, satellite images can be taken in different ways. If this is a point, and from horizon to horizon your satellite is passing, so when the satellite is looking at 90 degrees to that point, that's called the ortho imagery. You can take that, but you will not get the depth perception. But if you take it in the ascending node and descending node, you have two different perceptions. Just like in robotics or any kind of CV, you have perception building. We can actually do that perception building using satellite images as well. And doing that, we are able to predict the heights here, obviously with certain errors. And we can correct those errors using other alternative data sets. For example, in the US, you have aerial images, which are taken every 3 years. So that becomes a baseline, because it's very centimeter level. Here, we are speaking of 50 centimeter satellite images. Aerial images can be 6 centimeter in that case, drones or flights. Now, this helps us to essentially look at what is the current, define that risk categorization, and also define the change in the height after the pruning is done, what I was highlighting. However, it does come with its challenges that at a concept level, this seems very easy, but at an execution level, it is quite difficult. Satellite images are also not consistent in their quality. depending on cloud, depending on haze, smoke, lot of stuff. So doing the corrections continuously, making sure that the accuracy of your predictions are within the compliance requirements of these folks. Building the trust. I think most people underestimate that what is the effort required in creating a successful go-to-market strategy with a new technology. Technology is always cool. You can do a lot of stuff, but trust me, building a working GTM is more expensive than building a working product. Just the aspect of building the trust with your customer, validation, you need to have customer, and within the customer, users who are savvy, who are willing to fail with you sometimes. And why does that scope of failure exist? Because the models that we build, they cannot be global models. Unlike other AI areas, let's say LLMs, which you are applying on text, etc., here, the variation of your outputs can be because of different tree species, different agroclimatic zones, very different kind of, very, very different kind of tree concentration. Sometimes it can be dense, sometimes it can be sparse. So the way to develop the product itself gets locked with geography. You cannot, even though the satellites can collect data globally, you may want to only develop a successful working product in 2 or 3 geographies, where your confidence interval is is properly defined. And of course, when it's this kind of new novel technology ingestion that happens, and this is why 7 years and only Series A, is that you are building the markets effectively. You are building the business case with your customers. So these are some of the key challenges that a company like us all faces. And we do that sometimes on our own, sometimes with consultants who are working with the customer. Let me give another case study in agriculture. Now, agriculture and satellite imaging, while I don't know how familiar it may seem for this group, but it's quite well understood, at least from a policy and governance perspective. For example, in India, our space program was very much focused on national development and communication satellites and remote sensing satellites, where the places where we excelled before we started doing space exploration through more well-known Chandrayaan, Mangalyaan missions. Now, what had happened is that while the imagery and the crop statistics generation at country level was being done by ISRO, ISRO's mandate was never to go and commercialize. And that required a lot more product development. So the genesis of Satshare also happened like that. Me, my co-founders, most of my team were from ISRO only. So we started the company by understanding how we could actually create business cases. So when we looked at the amount of imagery that was available, in agriculture, the first and foremost thing is that you could actually create or simulate the different stages of crop growth. Because when the crops are very young, so in the imagery, the color starts changing from the brownish soil color to slight green interference. When it goes to the peak level, you can identify based on the time series modeling. It's just data at the end of the day. Time series modeling, what's the stage at the crop, and potentially what is the crop if you have a feedback data, training data from the ground. So all of this different information, sowing, harvesting, crop health, the tillage, etc., yield, these are all time series modeled using satellite images and provided with some feedback data to what we call as creating digital twins. Digital twin is not a new concept, but in the context of agriculture, imagine you're sitting anywhere in the world and you can go and check your farm, or you can go and check your entire set of portfolio of farms and be able to derive up to 95, 98% accurate information what's happening. So that is what capability we developed very early on, and that is also the reason why we could productize it for different use cases, whether it's banking or insurance or commodities here. So I'll give an example of how we are using it in supply chain, especially with agribusinesses. Now, most of the chemical companies who are building the molecules, for them, they have long R&D cycles. Per molecule, they will spend 10 to 15 years of R&D. And then they get into distribution, the different varieties of genetically modified seeds and fertilizers, green fertilizers, etc. So it's very important for them to expand the revenue, the business fast, because of the long R&D cycles. Now, if you look at what is the function of revenue, it is basically dependent on how many farmers each one of these companies have, and each one of the farmers have certain amount of farm area. So you can essentially do a market study that based on the number of farmers, what is the percent in market share you have out of the country's entire, let's say, 150 million hectares. Are you capturing 10% of the market because your growers have 15 million hectares all put together? So once this information is available with them, which they obviously have, they use the kind of cropping patterns data that we are generating and identify micro markets, saying that, okay, these are the demand pockets. The demand pockets now are no more concentrated by their physical presence on the ground. They now know that with the entire country at a gridded level, at a village level, where the highest concentration of the crops are, where they could sell their products, upsell their products, cross-sell their products, create new distribution, create new retailer cycles. So this goes into complete supply chain insights. How do they plan their inventory? How do they plan their production, etc. And it's a very simple value proposition. If you can say that in the matter of 10 years, you can increase your revenue by $100 million because of better, sharper view of the market, then what are you willing to pay for this? That's our business at Satshare, within, let's say, agri-businesses. And we work with quite a few companies in this space, providing them with the data insights that are then worked upon by system integrators in creating different service management, sales, marketing, like custom offers to their growers on the digital app platforms, etc. So we are like a data infrastructure as a company. So all of this, I'm just giving some examples here, are different applications of some core capability that we have built, which is being ability to process the satellite images, the ability to use AI to actually generate repeatably good insights, and last but not the least, packaging them to use cases that are relevant from a business perspective. While all of this we are doing, we also had to struggle with own challenges of the data collection itself from satellites. And that's where Gen AI came. So we actually have patented solutions around this, that there are different kinds of satellites. The ones you see on Google Maps, the great looking satellite images, those are called optical satellite images. You can see it from the eyes. But there are imagery that doesn't need to be in optical. It can be in different bands of infrared, microwave, etc. So those are radar satellites, those are thermal satellites. Now what happens is, only radar satellites are the ones which can collect data if it's cloudy. And by the way, we are in the tropics. It's always cloudy here. So we had to figure out a way to switch between data sets. Meaning, if I am not having an optical data, but I can collect through radar data, can I deepfake a radar into an optical? Because you cannot generate an insight without the optical information many times here. So this kind of jugglery we had to do, which was not because we wanted to be in the Gen AI space. Before Gen AI became cool, we already had this patent in 2020. So now, why are these interesting? Because we speak of Gen AI in so many more direct like usage context, ChatGPT, who doesn't know it? But people may not think of Gen AI in the context of satellite images, and it's still so relevant to enhance the amount of information that we are collecting about our planet, not have loss of data here. And yet, while the opportunities look very, very exciting, it can be very drudgery and dreary work to actually deliver results, because there's a lot of field data collection that is required. Now, unlike in the context of, again, creating a ChatGPT, where you can scrounge through the internet and create massive amount of billions of parameters to train on, in the context of satellite images, the feedback you need is the real what's happening on the ground information. So for that, there is no such government data collection repository that's available in a clean format. So companies like us, who were early movers in the space, we had to do this ourselves, build the entire data collection system ourselves. That can be, number one, expensive. Number two, non-transferable, meaning that what I do in India need not work out in Kenya or Brazil. And hence, it becomes important to create business model where the maximum reuse of your AI models happens within different industries. So this is not a one segment SaaSifiable, if that's a word, kind of a technology. And obviously, at the end of the day, again, the same things, business case development, because this is new technology. You are essentially triggering a business process re-engineering maybe at your client's end. So these are some of the challenges that how do you not only build the product, but what kind of GTM team you need. Sales people who can understand a bit of tech people who can understand a bit of sales. And that's why I think most of the big companies are not into this, and startups like us have to get into it. So last but not the least, I see I have 10 minutes left. Yeah. Last but not the least, a bit about one of the big moves that as a company we are taking, and I'll tell you why we are taking this as well. We have been using imagery that is either openly available, because public space agencies make this repository of data available, and it is quite updated, meaning that if the image is collected yesterday, I will have access of that imagery through an API today. So those kind of like, at least the taxpayers' money are being used well by space agencies, no corruption anywhere that we can ratify. But it has its own challenges as well, because the government will not make open imagery of all types. They will make open maybe coarse resolution, of which you can get maybe 50% of the information, maybe even lesser number of applications that can be developed successfully. While there are also commercial companies from whom we have sourced images, and we continue doing that, the pricing of those imagery has been extremely high, because those satellite companies' business case was totally defense oriented. So they have no incentive or capacity to reduce the price here. Hence, we started working on our own payload systems, because, by the way, that was a natural love. I am an aerospace engineer, used to work as a propulsion systems engineer. Imagery and AI was not my thing. We just adopted it. So for us, we had to define that what is the right quality of imagery we would need, but also how can we achieve the right price. Now, how many of you remember a few years back, is this news about ISRO launching 100 satellites? Raise hands. Hundreds? Quite a few people remember that, right? Excuse me. So that was almost like the cusp of hardware innovation in the space industry that started. There was a company called Planet, and they were launching shoebox satellites with the camera that was powered from that was, let's say, a derivative of the miniaturization of camera and electronics technology in cell phones, and they brought it into space. And that company totally disrupted the way imaging satellites were built. So some few years later, we found that, okay, while the imagery they were collecting was massive and unimaginable, but the quality may not always be meeting the needs of the kind of applications we are building. Hence, we had to figure out how do we make use of such industry convergences to reduce the capex and collect more information per day. And that's how we defined our mission of 4 microsatellites at 1 meter, which is your Google Maps imagery resolution, while having 5 times more collection capacity than any other satellite. As of today, we have already done our testing of the imagery. What you see here is actually taken of the payload that was custom developed, indigenously developed here in Bangalore. And we flew the payload successfully to generate these images. From next year onwards, we'll have 4 of the satellites which can cover the entire Earth on a daily basis, meaning it's like an IoT in space. So that's the kind of innovation that can happen if it's a demand-driven innovation. Because we didn't have to build the satellites if someone else had built it. Honestly, we could have just remained as a platform and analytics company. But no one was doing the hardware innovation. And I am always very inspired by Steve Jobs, like so many others, that your true innovation and market disruption happens when hardware and software innovation meet together. I think that philosophy just met space. Thank you so much. I'm happy to answer any questions that you have.
Thank you, Prateep. The floor is open for questions, please.